We should watch Dude, where's my card?
All right. All right. So we took our test. Many of you got done. Some of you still need a little bit more time. My schedule today. Let's see. Fourth period today. I have a meeting in this building. So if you were like, dude, I'm coming in fourth period, and that's the only time ever that ever works for you. Sorry, I have a meeting in this building. I will then be in my office over there until about noon. Be back at about 1:30 till 3 in that office over there as well. So that's my schedule today. Tomorrow I should be in that office for the most part of the day after this class. And I'm also available first period in the office right over there. So I will not grade the test, or let me take it back. I might grade the test either today or tomorrow, but I won't put them in the grade book until like Wednesday next week. So if you needed more time, and just because it goes in the grade book doesn't mean you couldn't have had more time on it. You know, come in and see me, make it work. I don't really know my schedule too well next week, but I just want to let you know as far as today, tomorrow, which is Friday, from basically 9:30 on till 3, I'll be over in that building. So that's what we have. Sound good? All right. Do what we can for you. As I walked around yesterday, kind of seeing what y'all were doing, for the most part, it looked like you guys had a pretty good grasp on factoring, which is a tougher concept, but I think you went through it at a pace that was good. Some of you might not agree. I will tell you there is one Schoology that's on there. It's one question and it's matching, and I think it's like 8 questions as part of that one. So it's quiz 6, which I have as a due date of Friday next week. No, all the rest of those quizzes that are on Schoology, that the bonus through 5, you have until tomorrow at 11:59 p.m. What? Hanging out the phone. Perfect. All right. So I want to try and make sure I give you guys a skeleton of notes. This is these notes. It's a front and back. Did you get one? What? Yeah. So usually first period over there. Today, fourth period, I'll be in a meeting over in this building, so you can't do it during fourth. Huh? 7th today? Over there. Today, no, I'll be at Grandview. Tomorrow, though. Okay. Tomorrow. Everyone get one of these? So again, guys and girls, I want to make sure you guys have a skeleton of notes each day. This will allow you to kind of walk around with notes. All right. We are continuing with quadratics. A quadratic is something that is squared. If we worked with different things with quadratics, we took that quadratic, we allowed just to factor down, which meant there was no equal sign. Then we incorporated an equal sign and set it equal to 0. If it wasn't equal to 0, we made it equal to 0 by moving everything over. And that meant you solved where it had crossed. And then we're going to still use the equal sign, but now we're going to have it be y. Okay? And so we're going to talk about standard form of a quadratic. So let's say we had Let's say we had something like that. Now, if it sits like that, that means we can go ahead and factor it, correct? Yeah. I'm getting there. Okay, so I could factor that. If I gave you that problem, you would say my magic number is 12. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which two of those, both being positive, would add to be 8? Well, the 2 and 6 work, so I'd get x plus 2, x plus 6 for the most part. Okay, and yes, I did that without factoring, but I got lucky. Okay, so we had an equal sign over here, and we make an equal sign over here, make it equal to 0. But what I'm going to change on this is I'm going to go y is equal to that. So I changed where the equal sign is in reference to the problem. So the standard form of a quadratic, so we can hold on to this type of problem. The standard form of a quadratic looks like this. Y equals ax squared plus bx plus c. A, b, and c are numbers. So if we look at the quadratic above, what is my a value? What do you think? 1. Okay, 1x squared. So 1 is it's just whatever the value is. What is my b value? 8. And my c value? 12. So a is 1, b is 8, c is 12. So everyone see how we got that? So when we're dealing with standard form, it means that we are in descending order. We don't have any more parentheses. It's all multiplied out. Y is on one side, and everything else is on the other side. Okay, so that's what our standard form looks like. We're going to start graphing quadratics. And graphing quadratics, there's a few different ways to go about it. I will just tell you that as of right now, our quadratics that we will deal with for the next couple of years will open up or they'll open down. Now, there are quadratics that open right and left. For the most part, unless you're in calc, you're not going to see a quadratic opening right or left as far as high school goes. Okay? It doesn't mean they don't exist and they're not important. It's just we're not going to work with them. Okay? So, what determines if a parabola opens up or down? If my a value is positive, then it opens up. Okay? So, with that little snippet of information so far, does my parabola, or my quadratic I have listed above, y equals x squared plus 8x plus 12, does it open up or down as far as you know right now? Opens up. Why would you justify up? It's a positive. It's a positive one out front, right? It's pretty simple. So you will come across problems that will say, hey, does this parabola open up or down? And you have to put up or down. And then it'll say, why? My a value is positive. Simple as that. Okay? If my a value is negative, it opens down. So A determines the direction it opens. A is positive, opens up. A is negative, opens down. So some examples of ones that would open down could be like this. It would look like this. And that's a dance you'll learn later.
Oh, yeah.
Sorry, I had to dance a little bit. This would open down because that's negative. Any of the other signs in here do not determine if it opens up or down. It's just this lead coefficient here. If that's negative right there, this parabola itself will open downward. Okay? Any of you take science and you talk about gravity? And that the force of gravity is roughly negative 9.8 meters per second squared. And then you ask your science teacher, well, why is it negative? And they said, well, you're falling to the earth. And it kind of made sense at that point. You guys remember this? The reason why it's negative is because free-falling objects are a parabola, and the reason it's negative is a free-falling object would be this portion of a parabola right here. That's why the negative 9.8 meters per second squared, or the negative 22 feet per second squared, it's negative. It's because the math behind it is because you're talking about a parabola that opens upside down. You're talking a portion of the parabola, not necessarily the whole thing. Am I following my notes so far? Okay, standard form, we talked about graphing quadratics. So we're talking about it if it opens up or down. In high school, it's rare to have parabolas that open right or left. Okay, let's talk about the vertex of a parabola. Just by looking at the green parabola, one on the left, would you think the A value is positive or negative? Positive. It's positive, it opens up, it's positive. The blue parabola, would you think the A value is positive or negative? Negative. Okay? The vertex of a parabola is where it changes directions. Meaning, if I were coming down here, I get to here, and now I'm going to start going up. If I was going up here, now I'm going to start going down. So it's the region where it changes directions. On this parabola where it opens up, this is the lowest point. In math, we will call that a minimum. Is that okay? Does that make sense? Anyone want to take a shot at what that would be? Maximum, so it's the highest point. The highest point of this parabola, and it's a maximum. Okay? So any of you who have taken the ACT or the SAT or any of the other standardized tests, you might talk about maximums, minimums. Basically means you're talking about the vertex if you're talking about a parabola. Now there's other things in math that are called local minimums, local maximums. We're not there yet, but right now the lowest point of a parabola is the minimum if it happens to open upward. If the parabola opens downward, the maximum height of the parabola is the highest point, and they're both going to be the vertex. The vertex is a point. If it's a point, I can label it as x comma y. So I have an ordered pair to get there. Is this okay? Okay, so let's kind of refresh. We worked with quadratics, we solved quadratics, we factored quadratics, we had special quadratics that were difference of two squares sometimes. Every now and then we find a quadratic that could not factor, and we called it prime. Okay? So those are all some things that we've kind of learned up to this point. We just learned that we were going to deal with parabolas that either open up or down. If the A value is positive, the parabola itself opens upward. If the A value is negative, the parabola opens downward. The vertex is the lowest point, which is a minimum, if the parabola opens up. The vertex is the highest point if the parabola opens down, and that's also called a maximum. The vertex is also a point which can be labeled as x comma y to find you a region in space on a graph. Sound okay so far? Anyone not meshing with everything where we're at? Okay. We now want to find the x component of the vertex of a parabola. I'm going to show you how to find this right here. After that, we're going to find the y component. Okay? To find the x, let's see, sounds good, sounds good, sounds good, sounds good. To find the x component, we're going to use this. Negative b over 2a. Negative b over 2a. What do you think b and a?
The alphabet.
The alphabet. Good. It's first and second letter of the alphabet. I love it. Where else does a and b come from? We just saw it on the standard form. Where's the a value located on standard form of a parabola? It's next to the x squared, correct? Where does the b value fall? After the x. So if I have y equals ax squared plus bx plus c, this value here and this value here are the two we're going to use. We're not too worried about the c value at this point, but using the a and the b value. Okay, so to find the x value, we're going to use negative b over 2a. Okay, do you think a and b could have a positive sign? Do you think a and b could have a negative sign? Do you think a and b could have one of each? Yes. So you have to watch your signs. So let's take a look at this. If I had y equals 3x squared minus 5x plus 6, first up, does this parabola open up or down? Up. How do you know? Positive where? The a value is positive. The a value is positive. That's going to indicate the parabola opens up. Okay? If the parabola opens up, is the vertex going to be a minimum or a maximum value? A minimum. Okay? So now I want to find my x component of my vertex. So I know my a value is equal to 3 and my b value is equal to negative 5. I guess I could list my c value being 6, but we're not going to use it quite yet. Okay? So I know that my a value is 3, my b value is negative 5. Do I want to feel comfortable with how I just found that? So now I'm going to utilize this. So I'm going to go negative because of that. What's my b value? Negative 5 over 2 times my a value. What's my a value?
3.
3. If I have a negative, what do you think happens?
Positive.
You guys are nailing this. So because I have both of those, that means I'm going to have a positive 5. And then 2 times 3 is 6. What is my x component of my vertex? 5 over 6. So my x component of my vertex is 5 over 6. So we don't know what the y value is at this point, but my x component is 5 over 6. Does that feel okay? Now, I made this one off the cuff, so having an x component of 5 over 6, it's not nice. Okay, so what I want to do is I want to put up another example, and we're going to find the x value, which will then lead us to find the y value. But I want it to be a nice, something nice. Okay, meaning a nice whole number, not a fraction. Not to say that fractions aren't utilized, but I want you to get the point of how this works, rather than dealing with a fraction and then all of a sudden you're like, this isn't good. Okay, so can I clear this off and try a new example? Okay, so let's do, I know I'm going to use negative b over 2a. That's my x component of my vertex, and then I have a y value. So I'm going to create a one that's going to hopefully work a little bit better. Let's go with 5x squared plus 10x minus 7. What's my a value? 5. What's my b value? 10. My c value is what? Negative 7, but we're not going to worry about it right yet because we're not going to utilize it. Okay? Using that information, I can find my x component. Does this parabola open up or down? Up. How do you know? The a value is positive. Okay? So, utilizing this, I'm going to get negative b, negative 10 over 2a. Is this going to be a positive or negative answer? Negative, okay. So this is going to give me negative 10 over 10. What's negative 10 over 10? negative 1. What is my x component of my vertex? Negative 1. Does that negative 1 indicate if the parabola opens up or down? No. What indicates whether it opens up or down? The a value. The a value is what? Positive. I got an x component of negative 1, but that negative 1 has nothing to do with the vertex or the direction that the parabola is opening up or down. The a value, only the a value, has something to do with it. Okay? So now I want to find the y value. Okay? I have the x value right now. I know that on the x-axis, I'm going to go to negative 1 and some other direction, up or down, to get me my answer to my vertex. So I'm going to take that negative 1, which is an x value. Does anybody see places I can plug an x value in up there? Where? Yeah, I have an x here. I have an x here. What does our equation equal? What does this whole thing equal? Y. What am I looking for right now? I'm looking for y. Okay. So if I take this x value here, plug it into these x values here, and solve this, that's going to give me a y value, which means that'll be the y component of my vertex. So I'm going to go y equals 5, some quantity squared plus 10, times some quantity minus 7. What was here and what was here? What was here? X, what was here? What's going to go there now? Negative 1. Negative 1 goes here. Negative 1 goes here. Order of operations is important. I do the exponent first. So negative 1 as a quantity squared is what? Negative 1 times negative 1 is 1. So this is going to yield me 1. And then I'm just going to rewrite the rest like this. So we took care of the exponent part first. Are you still with me? Okay, 5 times 1? 10 times negative 1? And then minus 7 comes along for the ride. 5 minus 10? Negative 5. Negative 5 minus 7? Negative 12. My vertex is at negative 1, comma negative 12. My vertex is at negative 1, comma negative 12. So if you had an xy axis at negative 1, negative 12, I would have my vertex to my parabola. As far as our parabola is concerned, did it open up or down? Up. So is that value a minimum or a maximum value? Minimum. Okay, so right now, my parabola is going to probably do something like this. Okay? My vertex is at negative 1, comma negative 12. So is that exactly what my parabola looks like? Probably pretty close. I don't know. We might be off a smidge, but I can tell you that negative 1, comma negative 12 is guaranteed to be one of the points on that parabola. Okay? So the vertex is a point. It's an x, comma y value. Now, I'm going to squeeze something up here. Can I erase this right here? Does anyone need this still? Everyone okay with how I got there? We'll work another problem. Don't worry. I know you're not losing yourself, you're losing sleep over it, but there's a term. What was that next term on our notes? What does it say? Axis of what? Symmetry. Axis of symmetry. I spell symmetry right? Or is there one out? Axis of symmetry. Okay? This is the most forgotten thing, and it's the easiest thing to find. Ready? Eyes up here. Ready? The axis of symmetry of this particular problem is x equals negative 1. X equals negative 1 is a vertical line. A vertical line has an undefined slope. X equals -1 is a vertical line that goes right through -1. And my axis of symmetry comes right through, and cuts my parabola into two equal things. This acts as a mirror. Okay? If I were to take this point over here, right here, and fold it over this line, it would match up. Okay? You can take the parabola, it's symmetric. I can fold it over on top of itself. Okay? It's kind of like your right and left hand. They're symmetric to each other. They lay on top of each other. Yes, I understand. Some of you might have a shorter finger, longer finger than others. I get it. But for the most part, your hands are symmetric. A parabola is symmetric about itself. A parabola is symmetric about the axis of symmetry. The axis of symmetry is only the x component of the vertex. So if you find the vertex, do you know the axis of symmetry? Yeah. Let's say I had a vertex of 7, 10. What is my axis of symmetry? If I had a vertex of 7, 10, what is my axis of symmetry? X equals 7. And don't just say 7, because x equals 7 means you're talking about a linear equation. It happens to be a vertical line. If I had a vertex of -200, 50, what is my axis of symmetry? X equals -200. Okay? So again, the axis of symmetry is something that's forgotten over and over and over. So if I had -200, 50, my axis of symmetry would be x equals -200. Okay? If my vertex was smiley face, frowny face, my axis of symmetry would be x equals smiley face. What does that mean? I'm just saying. Smiley face isn't a number. Sorry.
So it's whatever x equals.
X equals whatever the vertex. So as soon as you find the vertex, so this right here is your axis of symmetry. This right here is your axis of symmetry. So as soon as you found your vertex, as an immediate thing after that, right, x equals whatever the x component is, you find your axis of symmetry. That's always going to be 1 point for you on a quiz right there, or on a test. Okay, easy 1 point. Can I clear this? Is this okay to clear? All right. Let's do this. Okay, I want to go through this with everything we know, and then I'm going to incorporate the roots. Okay, does the parabola open up or down? Up. Why? What?
A value is positive.
A equals 2. There's your reason. Okay, A is positive. What is my A value? What is my B value? What is my C value? -6, but we're not too worried about it right now. Does the -4 or the -6 dictate whether it opens up or down? No. Okay. Next thing, I want to find my vertex. So -b over 2a, and then my y value. What is -b So I have negative, what is b? Negative 4 over what? 2.
2.
Okay. Negative is?
Positive.
Good. 4, or 2 times 2 is?
4.
Okay. So I'm still trying to find this y value. What's my x value equal to?
1.
1. Okay. What's my axis of symmetry? So my axis of symmetry is what? X equals 1. The reason you want x is that tells you it's a vertical line. X equals a number is a vertical line. And we all know that a vertical line has a undefined slope. All right. How am I going to find my y component of my vertex? What am I going to do with the 1? I'm going to plug 1 into my x's. So I'll plug it in here and here. So I have y equals 2 times 1 squared minus 4 times 1 minus 6. 1 squared is how much? 1. Okay, so y is equal to 2 minus 4 minus 6. So the y component, 2 minus 4 is negative 2. Negative 2 minus 6 is what? Negative 8. Okay, what is my vertex? No, what is my vertex? What is my vertex?
1.
What is my vertex?
Positive 1, negative 8.
Positive 1, negative 8. Thank you. This is my vertex. Being this parabola opens upward, is the vertex a maximum or a minimum? A minimum, okay. So, now I want to think about the roots. I think that's the next part. The roots. This is where it crosses the x-axis. Remember, some of them we couldn't factor them out. They're called a prime. That's going to mean something here. Yeah.
Can you find the maximum and minimum from here?
We've already found it.
Oh.
The vertex.
Got it.
So at x equals 1,
okay.
my minimum value is negative 8. Does that make sense how I said that? Perfect. All right, let's find the roots. So I'm going to take our original problem, and I'm going to forget about y equals. And what I'm going to do is I'm going to then set it up to look like this. So our very first step when factoring was? Huh?
Oh, check for greatest common factor.
Greatest common factor. This is our GCF right here.
Yeah.
Yeah, I can factor 2 out. That leaves me x squared minus 2x minus 3. I'm not really worried about this. I mean, I technically could bring it down here. So let's see. The factor, what is my magic number? Negative 3 times 1, negative 3. So I know my signs are going to be positive and negative, yes? And then in order to get 3, I go 1 times 3, yes? Which way would I have a negative 2 if I were to add 1 and 3 together, 1 being positive, 1 being negative? Okay, so I'm going to factor this. X squared minus 3x plus 1x minus 3. I look at these. What do I have in common? X. I factor an x out. I'm left with x minus 3. Still with me? If I have nothing to factor out, I have to keep it as a 1. So I have 2, x minus 3, x plus 1. This 2 is not going to do anything to our problem. Okay? My roots, I'm going to take x minus 3, set it equal to 0. So x is equal to? Positive 3. X plus 1 equals 0. So what's x equal to?
X equals
Negative 1. Okay? On a graph, we're going to do this. Okay? I know that at negative 1, I have a root. At positive 3, I have a root. So this is the point 3 comma 0. This is the point negative 1 comma 0. Still with me? I found I had a vertex where? 1, negative 8. At 1 and negative 8. I have a vertex. Okay? If I draw my parabola, it's going to go through this point. It's going to go through this point. What is my axis of symmetry? What's my axis of symmetry? X equals 1. So that means that I should be able to fold this parabola over on top of itself. It lies right on top of itself. So that means that, see how if I count this way, I go 1, 2. If I count this way, I got 1, 2. So look at that. That's 2 and 2. So this point's over here. So that means over here and over here, I can count over, and over here and over here, I count over. Okay? One last little point. Let's see. Find the roots, symmetry. One other point. Yeah.
Is there going to be an instance where a parabola isn't actually symmetrical?
It'll always be symmetric, yes. It won't always cross the x-axis, though. And when it doesn't cross the x-axis, that's one of the cases when it becomes prime. So we couldn't factor it. Okay? All right, hang on. We found the roots. Whew. All right. You have 90 seconds. 90 seconds side of that sheet. Okay? On the front side, we went through the parabola. We found out how to figure out if the parabola opens up or down. It's related to the a value. If the parabola opens up, the a value is positive. If the parabola opens down, the a value is negative. Still with me? We also figured out where we could find to get the vertex. And the vertex, we have to make sure it's in standard form. So that's descending order, where you have an a value, a b value, and a c value, where the a value is attached to the x squared, the b value is attached to the x, and the c value is the constant. It's the numeric value. Okay? And is it possible that any of those values could be 0? Yeah. The a value being 0 means you're talking about a straight line. It's no longer parabola. Okay? So if you had 0x squared is just 0. So it wouldn't be a parabola any longer. We also talked about the vertex. In order to find the vertex, we use negative b over 2a. Then we take whatever that value is, plug it back into x to find our y value. Our axis of symmetry is always x equals the x value or the x component of the vertex. It's the mirror that allows us to fold the parabola over on itself. One question was, can we ever have a parabola that's not symmetric? And the answer is no. Now you can definitely have shapes in math that appear to be a parabola, but it might have a non-symmetric point. And that would mean automatically it's not a parabola, it's some other type of even raised graph, meaning x to the 4th, x to the 6th, x to the 8th, x to the 10th, things like that. But we're not there yet. Okay, so I think I covered that whole front page fine. Going to the back page. Make a table of values to graph a parabola where we build from the vertex point. So, is everybody okay with the fact that sometimes we had something that didn't factor and we called it prime? Remember that? If it's prime, sometimes that means that it won't cross the x-axis. Okay? If it doesn't cross the x-axis, the parabola itself is either above it opening up or below it opening down. Does that make sense how I just said that? So the x-axis, it might not cross. And if it doesn't cross the x-axis, that's a lot of times when we came across it, when we went to factor it to find the roots, that it becomes prime. Okay? All right, so using still this problem, let's see, I have y equals 2x squared minus 4x minus 6. Can I clear this board? Oh, one thing I want to write down, my vertex is 1, negative 8. Okay. Let me clear this board. Sometimes you might have to make a table to figure out more points. Okay? So if I make a table, I'm just going to call it x and y. Okay? What I'm going to do is I'm going to make the very middle of this my vertex. I'll label it V. And this is how you go about making this table. I'm going to look at the x component. What is one number to the left of 1? 0. What's a number left of that? What's a number to the right of 1? What's a number right of that? Now, you remember when we said a parabola is symmetric about the axis of symmetry? The axis of symmetry is x equals 1. Okay? So, whatever my 0 value is will be what my 2 value will become. Whatever my negative 1 value is what my 3 value will become. Now, it's pretty easy to plug 0 into our problem. Do you agree? So if I take this, I plug it into our problem, I get 2 times 0 squared minus 4 times 0 minus 6. What's 0 squared? 0. 2 times 0 is? Negative 4 times 0 is? 0 minus 0 is? 0. 0 minus 6 is? Negative 6. So 0, negative 6 is a point that exists on our parabola. Okay, now I said that we are symmetric about the vertex. We're symmetric about the axis of symmetry. Okay, so if I was one number to the left of 1 to get to 0, if I want one number to the right of it, what do you think the y component of that point would be? What do you think this y component is going to be? Huh? Negative 6. Okay? Remember, it's symmetric. So I went one number left, one number right and left should be the exact same y component. What's easier to plug in, negative 1 or 3?
Negative 1.
Okay, well, I'll go with that. I'm always with you. So I get y equals 2 times negative 1 quantity squared minus 4 times negative 1 minus 6. We got to watch our signs. Shh, hang on, eyes up here. What is negative 1 squared? That's the same thing as saying negative 1 times negative 1. 1. So I get 2 times 1 minus 4 minus 1 minus 6. 2 times 1 is how much? 2. Negative 4 times negative 1. Positive 4 minus 6. 2 plus 4. 6 minus 6. Ooh. You know what those zeros indicate? Those are my roots. Now, it's not always going to happen that way. We got lucky. But if I were to go and start graphing this problem like we had already started graphing, and we can graph this on our grid that's there, okay? I have my vertex at 1, negative 8. I have a point at 0, negative 6, and a point at 2, negative 6. I have a point at negative 1, comma 0, and a point at what? 3, 0. Okay? This is my parabola. If I draw my axis of symmetry in, it's basically this. Okay? The axis of symmetry really isn't part of the picture, but it's nice to draw it in there. Okay? So what really this parabola looks like is you have this axis of symmetry. Get out there. Get my eraser. My eraser's not working right. Let's do this. Yeah. Silly board. So my axis of symmetry is actually just this. Kind of this dotted line. There's no reason to make it a solid line. If you do make it solid, you're not wrong. Okay? So, things to note on the parabola. Vertex. What else do I have? Thanks, not a problem. Vertex, axis of symmetry. Thanks, not a problem. Roots. Thanks, not a problem. Almost done. Y-axis crossing. Sometimes the y-axis crossing, the easiest point to forget on a parabola. 0, C is your y-axis crossing. Okay? Guys and girls, your assignment, and if you want to take a picture, you can, is, looks like page 39. There's 4 problems. Page 39, which says, it's worksheet number 1, page 39. If you need to take a picture of it, it's up here in this tray. Ruby Hancock.